Hello and welcome to a stream. I've not really done streams before, so this is something a bit different for me. The aim today is to test out a question. So let's resume. Normally when people are building megabases, they design everything to use stack inserters. And I actually have no idea what the UPS implication of stack inserters is versus fast inserters. And if we do a quick speed check on one of these, once it has a recipe loaded. Come on bots, load a recipe. Okay. So this uses 0.5 fast inserters and to fill and 0.6 to empty. Fast inserters obviously are a lot less efficient in terms of movement to stack inserters. We can't get away with a basic inserter with this fully beaconed. It needs more than 1.5 to load it, 1.8 to empty it. Now, when you're building these things early game, you use the cheapest inserter you can because the inserters themselves cost material to make, and the stack inserters are quite expensive to make. In late game that's irrelevant, but in early game that's really quite important. Once you're doing megabase building, the materials cost is irrelevant. It's the UPS cost which you need to watch. So what I'd like to find out, okay, there's an issue here with my inventory filling up. Let's get rid of those. Try again. So what I'd like to find out is there a UPS win or loss using fast versus stack inserters? So basically, from a UPS standpoint, do we want to try and make sure to use either fast or stack inserters, where we have the choice between both? Now, this is my base in a box world, which is running at about 1.9 science a minute, but has capacity for about 2.5 if the rockets were launching fast enough. So this has just a vast quantity of smelting, and a lot of it will be active. So what I'm going to do is go around, use the upgrade planner. I'm using the upgrade planner to swap all stack inserters for fast inserters, so greens for blues. As you can see, the builds continue to work. There we are. Let's go up to steel smelting. Okay. Then what we're going to do is use the benchmark command and see if they actually show a different speed when we run them with benchmarking enabled. Now that's not a bulletproof test. If we're doing it carefully, we'd have to run the benchmarks multiple times. We'd have ideally do some sort of significance testing and all that stuff, which nobody cares about because this is only a game. But I think we can probably get a number out of this if we run it for 2,000 ticks, or if that's not enough, 5,000 ticks, and see if there is an obvious, clear difference. If there is, that's useful to know. If there isn't, I would continue to use stack inserters because by the time you get to this far in the game, it's easier to work with fewer types of item than more types of item. So in your building train or whatever you happen to use, it's easier to have more stacks of stack inserters than to have some of stacks and some of fasts. Just as it's easier to do everything with blue belts if you can, rather than having to carry around 3 different colors of belts. Okay. So I should say I'm using the upgrade planner mod for this. And I've set the upgrade planner recipe to replace stack inserters with fast inserters. Okay, so that's it. This is the last bit of smelting. Okay, so we have changed over nearly 3,000 stack inserters for fast inserters. So 3,000 entities, I know they're not live all the time, but 3,000 entities is significant. Let's save this game. So this can be called 12 fast. Okay, so that's going to save out. You can see the map is a significant size. And I'm going to quit the game because when we do the benchmarking, I want the computer to be as free as possible from other load. I'm also going to shut down my web browser so that Facebook isn't chewing through all my resources running pointless JavaScript. Okay, now I don't know how well this shows up on screen. Let's make it bigger. All right. So, the way you run these is it's the Factorio binary, then it's ~benchmark, and then your save file, which is normally in the saves directory. So this is base in a box 12 stack. Then you have to tell it how long to run the benchmark for. So I would like to run this for 3,000 ticks. 2,000 ticks. Let's do 2,000 ticks. And this should run for a little while, okay? So what happens is I hit enter. It starts loading up Factorio. And Factorio goes through the normal processes of loading in the mods, loading in the sprites, loading in the base. And then it gets to 90%, 89%, and it hangs 90%. And this is where, if you haven't done this before, you panic because you're like, what the hell's going on? What do we do now? But what's actually happening is if we flick back here, it's now running through the update ticks. So you can see it's done 1, 2, 3, 400 ticks, and so on and so on. Okay, so we will watch. Have I crashed something? I hope not. Okay, so I think Factorio is being less than responsive while this is going on. In a minute, this will have gone through its however many thousand ticks. Here we are. So it did 2,000 ticks in... Here we are. These are the vital stats. Okay. So I'm going to just save these into a text editor because, as you've probably noticed by now, my memory is appalling. So I'm going to copy that, paste it over here. But just so everybody knows, it ran for 42 seconds. So 42,019.5 milliseconds. Okay. Now that was with the stack inserters. We want to do the same thing with the fast inserters. So this will load up, get to the 90, then it will start ticking through the counts in the other window. I'm not going to press tab this time to flip backwards and forwards. What I'm going to do instead is have a cup of tea. So this is the sort of thing which doesn't matter at all when you're building your base. Probably doesn't matter when you're building a 1K base. These are the kind of things which really only matter once you're building a base at the scale which your CPU can handle. At that point, you have to optimize your base to squeeze more base out of the same CPU. And things like optimizing the pipe usage, optimizing which inserters, doing circuit conditions, trying to minimize the number of trains, these all become an issue when your hardware can't keep up with the game. So, you know, for 90% of the time in most playthroughs, this is irrelevant. But on the other hand, if we can find some best practice, which you can do unambiguously, then why not? Okay, so this ran. And it took 43.9 milliseconds instead of 42. Okay, so let's run the stack filter again. Because 42 and 43 aren't really that different. Let's see how long this one takes. So I'm just copying these numbers around in the other window. But certainly there was no effect there where the fast inserters took twice as long to run or were twice as quick. And this is basically what you do for a while. You spend quite a while sitting around twiddling thumbs, waiting for your minute-long run benchmark cycle to end. I'm really tempted to write a script which you give it a bunch of save files and it goes through and loops through them, running them for various numbers of ticks, and then generates all the data and plots histograms. It's a bit like work though, so yeah. So this one ran for 41.6 seconds, which is pretty much the same as 42. That was stack. Let's run fast again. Okay. And if this, again, if the runtime for this again is within a second, I'm going to declare that stack and fast inserters have no meaningful UPS impact. But we'll see. I've run this before and just my computer being upset or paging the memory in differently or something has given radically different results. So, you know, swings and roundabouts. If you were doing this properly, you'd run these sort of 10, 15, 20 times. You'd run them for 2,000 ticks, 5,000 ticks, 10,000 ticks. And then you do some proper stats on it to see if the length of time the various saves ran for was significantly different, or the rate at which they run, the number of ticks per CPU seconds. However, my feeling is if you have to run something that carefully to see a difference, that maybe it's not a difference worth winning. Okay, so that came out at 44.1. That's interesting. I'm going to run it once more for each of them. The reason I'm going to run it a bit more is because we came up with 41.5 seconds. Then we came out with 43.9, 44.1 seconds for the fast inserters. So it does look like the fast inserters are marginally slower than the stack inserters by maybe 1%, 2%, in which case that's an interesting result. So let's run this a third time for both scenarios. What else is going on? So I'm currently pre-recording a design challenge I set myself, which was to build in creative mode a bunch of modular rail and bot builds for a 10K science setup. My PC probably can't run a 10K base, and in any case, I don't really want to build the whole base in creative mode. That seems a bit cheaty. Okay, what have we got here? 41.5. So this is starting to look consistent. All right, now let's do the fast again. Okay, so what I'm thinking of doing is doing a playthrough where I see how quickly I can blitz through the early game up to rocket launch, and then see how quickly I can blitz through to a 1K megabase, so exactly on the 1K, and then really use the 1K base as the starting point to scale up. Spoilers, I've discovered that a lot of the builds for the 10K build actually scale out quite nicely to 2.5K and then having 4 of them. So I think what I may do is see how quickly we can rush the start of the game, given that we are just building to get to the point where we can build our mega base. See how quickly we can build our mega base, and then I'm going to have a go at scaling up from that, from 1K science to 2.5K science, and then if that is still tractable on my computer, see if we can then scale that to 5, 7.5, 10. Okay, so this has come out again at 44.3. Okay, so this isn't exactly scientific, but I'm at this point willing to say clearly fast inserters and stack inserters don't have vast impacts upon UPS. So one or the other, it doesn't make a massive difference in the runtime. However, all 3 of the stack inserter runs ran 42 seconds or faster, and all 3 of the fast inserter runs ran at near enough 44 seconds or slower. So that's 2 seconds out of 42 or 44 seconds. That would be 4-ish, 4.25, half, I don't know, seconds out of 100 seconds. So it's possible that we are winning upwards of 4% performance by using stack inserters. And that is actually a good win. Okay, so the take home today is I think I'd have to obviously run this like 50 times to be really confident, but I think we could make a case that stack inserters are more efficient than fast inserters, even for smelting where they're moving single items, by about 4 to 5%. Okay, well, that was unexpected for me. I'm going to leave this here. I'm going to end this stream. Thanks so much for watching. We will make sure in future that we use stack inserters everywhere we can as soon as we can, because it's obviously certainly not a loss. Thanks so much for watching. I hope this stream will appear on YouTube as a recording if you didn't watch it live. Until then, thanks very much. I will see you again soon, and watch this space in a few weeks' time when I start releasing the 10K base build playthrough. All right, bye-bye.